Find the domain and range of the function g of xy equals ln of x squared minus 2y. First, for the domain, we want whatever's inside the log to be greater than 0. So that means that x squared has to be greater than 2y. For the range, we know that in general, the natural log goes from negative infinity to positive infinity for the range. Likewise here, no matter what we plug in for x and y, we're going to get all real numbers. Okay, now we want to find the level curve of the function at c equals 2 for g of xy equals x cubed minus y. Okay, so we're going to set g of xy equal to 2, and we have 2 equals x cubed minus y. So add y, subtract 2, we get y is equal to x cubed minus 2. So this is just a graph x cubed, but we're shifting it down 2 units. So instead of 0, 0, it's going to be 0, negative 2. And here there's going to be a horizontal asymptote, or horizontal tangent at x equals 0, and then we're going to go back up like this. Now let's evaluate the limit using algebraic techniques. Okay, so we have limit as x and y both go to 0 of x cubed minus y cubed all over x minus y. So we're going to factor out an x minus y, and we'll be left with x squared plus xy plus y squared, and that's all over x minus y. So the method to factoring this is you have 3 factors of x and 3 factors of y. So the idea is you want to pick each of these factors. So you pick an x and a y here. So it's like x and y. And then for the second parentheses, you group these. So x times x is x squared. X times y is xy. And then y times y is y squared. Now for the sign, you want to use the acronym SOAP. S stands for same. So you want to keep the same sign. Here it's minus, so keep it the same. O stands for opposite. So the opposite of minus is plus. And the last one, AP, is always positive. So that's how we factor it. And now we're just going to add a limit in front of it. The x minus y is going to cancel. And when I plug in x and y equals 0, I get my limit is also 0. All right, next, let's let z equal e to the 2x times tangent y. We want to find the second derivative, so dx dy, and the second derivative of z with respect to y and then x. So the only thing that changes is the order. So for the first one here, we're doing x first and then y. And then we're just reversing the order. We're doing y first and then x. Okay, so let's do dz dx first. The derivative of e to the 2x is 2 times e to the 2x. And then we'll multiply that by tangent y. Now we want to take the derivative of our previous answer with respect to y. So you treat 2e to the 2x as a constant. The derivative of tangent y is just secant squared y. Okay, let's move on to dz over dy. E to the 2x is a constant. Take the derivative of tangent y, which is secant squared y. And then finally take the derivative with respect to x. And that's just 2e to the 2x times secant squared y. And notice that these are exactly the same.